Welcome to part 5. Just a recap from the last video, we've basically completed stage 1, which is pulling the data and then doing minimal text pre-processing. So we successfully pulled RSS feeds, which still needs some updating. These are the current ones inside. But as we scale this project, we'll be including more RSS feeds. And then we've also pulled Google News data, given a few important keywords, and then also Reddit data. And all of this data was then concatenated into one major data frame, having this format over here, which is then saved as a raw file. And then we've also done the text pre-processing, which we then saved as another file. In today's video, I want to talk about starting the first stages of text analytics. And in this video, we will be focusing on the term frequency inverse document factorization. I think that's what TF-IDF is. But what TF-IDF does, term frequency inverse document frequency. So what we can do is we can count the number of words that occur in a document. In our case, it's going to be this text data over here, right? And we want to know what kind of words happen or occur the most in this document, right? We want to make sense of all of this text. But only counting the words does not necessarily give us more information, because Bitcoin, for example, can be repeated multiple times across the document, and it wouldn't really have that much value in the grand scheme of things, right? Because we want to understand the underlying topics that are being talked about. And for that, we have something called term frequency inverse document frequency, TF-IDFs. So there's two components to this. The first is, as we talked about, the number of times a word occurs, right, divided by the total number of terms in this document. So if a certain word appears 5 times and the document has 10 words only, right, this TF is going to be very high. But then we're going to discount high or highly frequent words by dividing that by the inverse document frequency. So we're going to take the total of documents that are in a corpus. So for us, it's basically going to be the number of posts pulled, which from last video is around 1,000 columns, which we can see 1,085 columns. And we're going to divide that number by the number of documents that contain that particular term. Okay, and then multiplying those two, I said divide, but you multiply it, then gives us helps us understand which words are really important in a document, right? So let's go ahead and do that first. So stage 1 is complete, and all of these findings we're now feeding into part 2. So this is kind of the second stage to the whole pipelining. So this is stage 1, and now we're going to build stage 2. So just for experimenting purposes, I'm just going to name this NLP experiment. Experiment.ipynb. We're now going to finally import the pre-processed text, okay, which are these documents. So let's get started. So we're going to import pandas, and then we're going to import these 2 documents. This is today, I already ran the script before starting the video, and then this is from yesterday's video. Okay, so I'm just going to say df1 for now is equal to pd.readcsv, and then we're going to go into data, then into pre-processed text, and then we're going to call this one over here. So copy. We don't need all of this. And then we're going to repeat this to df2, and this is going to be yesterday's data frame. And then let's go ahead and concatenate all of these. Is equals to pd.concat, and we're going to take df1 and df2. And then axis, or do we do axis is equal to 1? I think this is wrong, but let's just see what error we get. Oh no. No, wait. This is wrong. Fix this. I want to stack 2 DFs on top of each other. PD concat. Oh, axis 0. That one. So I'm just going to change this to 0, and then now we should have 2,000 rows. But we're also going to reset the index. Okay. Drop equals true. So this drops the original index. So now we have this. And then we have the pull date. So anyways, let's not get too much into the actual setup, but let's start the TF-IDF process and see what words really occur. So starting TF-IDF. I have a column in my data frame named preprocessed text, right? Start TF-IDF and make a matrix. Then sort it with the most important term. Okay. So to create a TF-IDF matrix, I got to import the libraries. So we got to import from sklearn the TF-IDF vectorizer, and then the text is equal to that. So let's just take this. Good. So df_all.preprocessed text is going to be texts, right? So we're just extracting that one column and making this into a list. And then we're initiating the vectorizer, and then we fit the text to the vectorizer, and then we convert this into a data frame, right? We get the feature names out from the vectorizer class, and then we calculate the importance. But this is not working. Expect np.nan is an invalid document. I think some says that there are missing values in your preprocessed text column. So exactly, we're just gonna fill the NAs for now. And now we see that Bitcoin is the most important term, crypto is the second most important term, then Solana, then new Ethereum. Okay, so in total we have 11,632 unique words, and excellent is the least important, probably was mentioned once or twice. Okay. So we got this. So now I want to make a word cloud out of this, right? And this kind of goes to this part over here, so we can visualize it a bit better. Now make a word cloud from the TF-IDF. Include 100 words. And word cloud is another powerful tool. A word cloud, what it is basically, it is a 2D map, and whichever word is the largest is the most frequent based on the TF-IDF, and then smaller words hold less importance. Okay, so this is what we're going to generate. So top 100 terms. So we're just going to need this, and I'm not going to display that, so I'm just going to run this, and then I'm going to put this into here. Select the top 100 from the term importance, right? Take the first 100 because it's already sorted, and then we're going to make the word cloud. But we do need to import another library, and this is WordCloud. So let's do that, and then run this. Plot is not defined because we need to import matplotlib. Import matplotlib as plt. Dot pyplot, and this is our TF-IDF visualized for easier understanding. So within the corpus of all of these texts that we pulled today and yesterday, these are the most important terms. So Bitcoin, by far the most talked about. Then crypto, markets, Solana, right? So it gives us a general understanding of what kind of words occur. And what we can do is we can actually compare how the word choices have changed over the past 2 days, right? Because we have the 3rd of September and then we have the 2nd of September. So we can kind of split these two and just look at DF1 and DF2. I'm just going to just make this code a bit more compact. Okay, and then actually we're going to make this into a function to show. I'm going to make a function for the TF-IDF and then a function for a WordCloud. Now you could even make this into a class, so you have a class and then you have the two and then call them, but I'm not going to do it for this video. Make a function out of this where you feed the text only. So we can just write this function ourselves. So define TF-IDF. We're going to import a text, just basically the columns. And what we're going to do is we're first going to set up the vectorizer, right? This part. And let's actually just take all of this. Indent this. Vectorizer, and TF-IDF matrix is going to be equal to the text that we get from here. And then this is going to be made into a data frame. And then the term importance, where we sort the values. And then we're going to return the term importance. Okay. And then next up, we're going to define the word cloud. So define word cloud. I'm just going to do word underscore cloud so we don't have any double mix-ups. And here we're going to import we're going to feed in another text file. And here, because this is all 11,000 words, so we're going to do top equals to 100. So right now it selects the top 100 words. And then I'm just going to copy this into here. So, top n terms is equal to top, which we take from here. And then we create the actual word cloud itself. Okay. and then this is going to be top entrance instead. And then we're going to display it. Okay, and for this, do we need a return? Is this function good, or do we need to return something? The function was almost correct, but there's a few improvements that it's not defined within the function. Term importance, because this is going to be text. Right. Return WordCloud, but we don't need it, such as saving the image to a file. Yeah, I'm just going to keep it like that. Okay, so these are the two functions, and I'm just going to take these into here, and then this is already a lot better organized, so I can run this, and then df1 or second September is equal to df1 preprocess text, and then 3rd September is equal to df2, and then the same. Okay. Oh, and then we're going to fill NAs with blanks. Okay. And then after that, we're going to feed these into the TF-IDF function. Because so 2nd September, we're just going to name it the same, is equal to TF-IDF, and then we're going to feed in 2nd of September. And then 3rd September is going to be equal to the same function, but we're going to feed in this text file. Let's run this and see if it works. It works. Okay, because this variable over here is basically this over here after running through all of this, right? And then now we're going to start the actual visualization. So 2nd of September, actually, we're just going to do WordCloud, feed in 2nd of September, and then top 100, and then this should spit out a graph. Perfect. And then what I'm going to do is plot.title is equal to 2nd September, but this would have to be done after it. I don't know. We would have to put it in here somewhere. Let's just do title. We're going to do title, which is a string. Right? Would this work? Nope. We don't want this. So that we're going to be a string itself. So we're going to do plot.show. We're going to do plot.title, which is equal to title. Okay. And then over here, we're now going to feed in title is equal to 2nd September. And this should do the trick. Because this is top is equal to 100. Okay, 2nd of September. And then now we're going to do WordCloud, but the 3rd of September. Top, we can just leave top 100, right? Because it's already set as default over here. But the title, we're going to equal to the 3rd September, just to keep it consistent. So these are now the two days worth of bunch of news data and Reddit data, and here we're comparing the terms. So on the 3rd of September, the word new is a lot more important. Bitcoin, crypto, Solana, all of these stay the same. What we could do is we could remove Bitcoin, crypto, Solana, and all of these big words from here because it's not really too informative other than knowing that, Bitcoin just appeared the most in terms of the words. So we can do that. By here we can ask ChatGPT actually. Can you make an addition to the function where we leave out a list of certain words? Okay. So exclude words, and this is going to be a list. So if exclude words is non-exclude words, stop words equals exclude words. Over here, stop words equals exclude words, and then we're just gonna make exclude words, if I can type properly, is equal to, and then here we're gonna make Bitcoin as one of them, Ethereum as one of them, Solana as one of them, crypto, Ethereum, Solana. Okay, let's just start with this. So I'm going to save this and then run this. Okay, so now we get kind of a more deeper understanding of the words and their importances. So for the 3rd of September, the word new seems to be very important. So this is indicative of something new, which I don't know yet, right? We're gonna have to do further analysis to figure out what this new is really related to. And we can actually do this, get more information with, I don't have it here, but I'm also gonna do n-grams. Okay, and what n-grams are is, instead of just analyzing one word, we're gonna take the importances of two words, right? So what we're doing over here, we're just looking at the importance of a single word. But what if instead of a single word, we look at two consecutive words? Like new chain could be one, market sentiment could be one, price data, whale selling. So we're just redoing this graph and the whole TF-IDF calculation, but we're going to be looking at consecutive words. We're going to be looking at consecutive words, and n-grams could be any. So we could look at the importance of two words or three words consecutively occurring. Okay, so let's go ahead and do that. If I wanted to make a TF-IDF, but look at bigrams, two words occurring after each other, how would I modify the input into the TF-IDF function? So we're going to have to modify the vectorizer itself. So n-gram range. So we're going to modify this thing. So, and here's where the beauty of modularity starts, right? So we can really scale the way that we analyze and fetch out different insights as we go. So n-gram range is a extra parameter that we will be including into this function, and I don't think anything else changes. Okay, so it's going to be ngram range, and then the input in the actual function will also be there. Okay, just like that. Explain to me ngram range is equal to nm. What do these signify? Okay. So here we're saying that n is the first value, m is the second, r is the largest n-gram size to be considered. Only, okay, so 2, so this would be only bigrams. Bigrams and, oh, so unigrams and bigrams. Okay, got it. So 2 would be essentially would be a bigram, and then 3 would be a trigram, and exclusively that. Okay, so let's exclude, let's just comment this out, save this, and we're going to keep this as it is, but now we're going to add the n-gram range, and we're going to do 2, and then the same over here. Okay, so essentially we're going to figure out now what new is, hopefully. Exclude words is not defined. I'm just gonna make an empty list here, and then exclude words. Actually, I'm just gonna keep it like that, and then run this. So now, so appeared first. Pepe, meme coin. So meme coin is one. Cryptocurrency market, smart contract. But what is new? Do we have anything new? So Vitalik Buterin is something that occurs. Invest new. Let's make these graphs bigger. Can I introduce a DPI in this to make it higher quality? Is equal to 300. Let me take this and ask ChatGPT how I can introduce DPI. How can I set the DPI? I want a higher resolution. Set a higher resolution. DPI. Where do we have this DPI? Generate frequency and terms. Okay, so it's going to be in plot figure itself over here. So DPI is equal to 300. There we go. Now we can more properly see. So this is pretty interesting. So because now we see which word pairs occur the most. So new cryptocurrency. What else? Invest new. Rate cut is something that's talked about. Tron is something that's talked about. Market buzz. Civil question. Major investor. Bitcoin miner. Predict 100x. Bitcoin ETF is something that's talked about. Interest rate. So interest rate is something that's really talked about. Crypto markets, right? What if we go into trigrams now? Trigrams is basically 3, right? So first crypto briefing, homework problem finance, appeared first crypto, question thread this, question personal finance, career seekers encouraged also, right? And then here we should have something with the word new. But on trigrams, it doesn't seem to be too popular. Reply, expect, construction, price, predict 100. Okay, so this is basically trigrams. But we're gonna go, let's try unigrams and bigrams, which means it will rank, it will aggregate the importances of both unigrams and bigrams. Okay, for the 2nd of September, so crypto. So we kind of understand now what is really being talked about in the data that we've pulled, right, with all of this. So this concludes WordClouds and TF-IDFs. And then in the next part, we're going to be looking at cluster maps and PCA, and then we're going to go into topic modeling. But yeah, thank you guys for watching.